Hello and welcome to Pharmacy Online. Pharmacy Online is a channel where we will discuss the topics that are related to the pharmacy subject. Today I am going to discuss the basic introduction of pharmacology, so let's get started. Pharmacology is the branch of science that deals with the study of substances that interact with the living systems. Substances here means any drug or the chemical. So it is also referred to as how the drugs work in the body. That is the drug actions. So it has two main areas, medical pharmacology and toxicology. Medical pharmacology is the area that deals with the use of chemicals in the prevention, diagnosis and treatment of disease, and toxicology is the area that is concerned with the undesirable effects of chemicals on the biological systems, that is the adverse or the toxic effects of the drug. So there are two main branches of pharmacology: Pharmacokinetics and Pharmacodynamics. In simple words, you can say Pharmacokinetics describes the effects of body on drugs, and Pharmacodynamics denotes the actions of the drug on the body. So let's see. Pharmacokinetics is referred to as the absorption, distribution, metabolism or excretion of the drug from the body. For example, if a drug is administered in a human body or any living body, it will first be absorbed, then it will be distributed, that is, it will be distributed in the target organ, and then it will be metabolized, that is, broken down, and after that it will be excreted from the body. So the study of whole of this process is called pharmacokinetics. This is basically what the body is doing with the drug. Now let's come to pharmacodynamics. Pharmacodynamics refers to the molecular, biochemical and physiological effects of drug, including the drug mechanism of action. After the distribution of the drug in the body, especially in its target organ, the drug will give a clinical response, and that clinical response can be a therapeutic response or the toxic response, that is the adverse or the toxic effect of the drug. So this is basically what the drug is doing to the body. Next are some general principles of pharmacology, that is the nature of drug, physical nature, drug size, drug reactivity and drug receptor bonds, and drug shape. Number 1 is the nature of drug. The drug may be defined as any substance that brings about a change in the biological function through its chemical actions. So in most cases, the drug molecule interacts as an agonist, that is the activator, or the antagonist, that is the inhibitor, with a specific molecule in the biological system that plays a regulatory role. And this target molecule is called a receptor. So the drug can be an agonist or the antagonist of the specific receptor. Besides that, the chemical antagonists may directly interact with other drugs. Some of the chemical antagonists, other than interacting with the receptor, they may directly interact with the other drugs. And osmotic agents interact with water molecules. Next is the physical nature of the drug. Drugs can be in solid form, that is atropine, aspirin, in the liquid form, example ethanol or nicotine, or they can be in the gaseous state, example nitric oxide. Or they can be divided on the basis of organic or inorganic compounds, example carbohydrates, proteins, lipids, and inorganic compounds, example lithium, iron, heavy metals. Number 3 is the drug size. So most drugs have molecular weight between 100 and 1000. To have a good fit to only one type of receptor, a drug molecule must be sufficiently unique in shape, charge and other properties to prevent its binding to other receptors. So to achieve binding, it appears that a molecule should be at least 100 molecular weight. And besides that, drugs much larger than molecular weight 1000 do not diffuse readily between compartments of the body. So so drugs should have molecular weights between 100 and 1000. Next is drug reactivity and drug receptor bonds. Drugs interact with receptors by means of chemical forces or bonds, and these are of three types: covalent bond, that are very strong bond; electrostatic, that are much more common than covalent bond, and they are not reversible in many cases, and they vary from strong linkages between charged ionic molecules, weaker hydrogen bonds, and very weak induced dipole interactions. And number 3 is hydrophobic bonds, that are quite weak, but they are important in interactions of highly lipid soluble drugs with the lipids of the cell membrane. Last is the drug shape. The shape of a drug molecule must be as such to permit the binding to its receptor sites via the bonds. Optimally, the drug shape is complementary to that of the receptor site in the same way a key is complementary to a lock. Furthermore, the phenomena of chirality or the stereoisomerism is so common in biology that more than half of the useful drugs are chiral molecules, that is, they exist as enantiomeric pairs. The more active enantiomer at one type of receptor site may not be active at another receptor type. Example, a type that may be responsible for some other effect. Here we have an example of carbidiol, that is a drug that interacts with adrenoceptors. It has two enantiomers, S enantiomer and its mirror image R enantiomer. The S enantiomer is a more potent beta blocker, whereas the R enantiomer is 100-fold weaker at the beta receptor. So that's all in the introduction of pharmacology. I hope you like my video. If you like it, please do like, share and subscribe to my channel, Pharmacy Online. Thanks for watching. See you next time.